Alright, here's 9-3 day 1. We're making the jump over to means. So I have 3 problems in here, pretty much just a couple follow-up questions on the 4 steps, but really 3 of them. Oh, just to give you a variety of cases and to highlight the things that are going to be different with means. As you read through the context here, good to be clear that this problem is measuring a mean. You took 12 randomly selected hours and measured in minutes how much music was played, and then took the average. Okay, so a mean is the appropriate approach here, not a proportion. We're not looking to measure the percent of anything. Here you can see your state step. We're suspicious that the station is playing less than 50 minutes. Okay? For random, I'd say we have an SRS of n equals 30. Whoops. Not 30. That's the magic number that we actually don't have. 12. I'll say hours. Say hours of music. The box plot would look like this. The center is just to the right, and then the right tail is a little bit longer. And all I would say with it is no major skews or outliers. Okay. Notice in the name of the test I said I'm going to use a T procedure because that's, again, almost always the case with means that we're going to be dealing with S and not sigma. This would all come from the calculator. That you would see that our average is 47.9. S is 2.81. The one sample t-test will also give you S. That's negative 2.57. This was done with 11 degrees of freedom. I got to state that. And then I would get that the p-value is 0.013. Okay? The different the different random condition that the different normal condition came up. Notice the notation of mu, the fact that I did a T procedure with degrees of freedom. Those are the main differences that we get from doing a mean instead of a proportion. Conclusions, is basically the same. P-value is less than alpha. We reject HO. There is convincing evidence that the true average mean number of music played by this radio station is less than 50 minutes. All right. Here's another one. It's got a little follow-up question to it. We'll do the 4-step on the next slide, but this one's going to be a greater than. That's really the only difference here. Still a one-sided test, but it'll be a greater than. Basically the same. If we were going to use the test feature, there'll be a tutorial for that. If remember with the T procedures, there's data mode and stats mode. These first 2 have been data, where you just dump all the data in list 1, and then when you go to the test, make sure it says that it's in data mode. All right, so the speed limit in the construction zone is 25. We'll throw another officer there if it's over. I think that's what they're saying. They're testing is if it's worth monitoring more closely. One thing I did notice, I may have made this mistake on the first one too. Somewhere in here, whether in the definition of the parameter or in HO and HA, I should specify that the units are miles per hour. Okay, that should be there. Look back to the first one. I did get in there, and when I defined mu, that mu is the number of minutes of music. But this one should get miles per hour in there. If you're feeling really confident, again, it's not a bad idea to pause and see if you can just crank out the whole thing on your own. You can always resume and check and see how you did. I believe they took a random sample of, you could say 10 drivers, 10 cars. They monitored the speed of 10 cars. It's less than 30. Remember the magic button of zoom 9. A little quirk on this one is you would see that left tail is a little bit longer, so I said it's slightly skewed, but no outliers, so we'll keep going. So the average of our drivers was 28.8. Parameter was 25. We had, whoops, I think we had 12. I got to back up here. No, we did have 10. For some reason I was getting down here thinking we had. Degrees of freedom would be 9. Zero, 0.069. I need a t-score, and I'm checking my notes here, and I did it off the calculator, but my t-score didn't quite make it, so I got a number crunch it here real quick. I believe it's right around 3.05. Yep. P-value is less than 0.05. We reject HO. There is convincing evidence that the true mean speed of the drivers is greater than 25 miles an hour. As far as the error probability, we reject it. Okay, which means could be making a type 1. We rejected HO when it's actually true. So we would conclude that the average speed is greater than 25. The effect would be that if that concerned us and we put, an officer to monitor speed in this construction zone, it would be kind of a waste, right? People, on average, really aren't speeding, and we think they are, so we're monitoring an area where we don't have any evidence that we think we have evidence that speeding is common, but it's really not. Okay, that's what a type 1 error would be here. All right, this data is off a fun little game called Don't Break the Ice, where you have all these like plastic ice cubes that are all jammed together. And you tap them out with this little hammer. And you want the cube to fall out, but not the whole thing. Okay, so this data is from the manufacturer of the game that is monitoring a couple things. First off, for this game to work well, these little cubes need to be 29.5 millimeters wide. Okay? Too big is bad. They won't all fit. Too small is too bad, and the fitting will be a little bit too loose. So this fathom output is telling us a couple things. As a simple random sample of 50 of the cubes that they produced. There's the average. Standard deviation of our sample is 0.093. Okay. This problem does ask us about these a little bit. 0.093, that is how much one cube varied from the mean. The number we'll use in our test statistic is this, which would tell us how much the mean would vary in repeated samples of 50. Okay, notice those two parts. A is really just the standard deviation. Of that sample of 50, the widths of the cubes vary by about 0.093 millimeters from the average. The standard error, right? This has always been the case since we've seen standard error. That number tells us how repeated samples of 50 would vary. Okay? A lot less. Okay, it would vary a lot less. Another one here where somewhere in this step I do need to say that the width is in millimeters. Okay? Got an SRS of 50 cubes. Normal condition is going to be a lot better, right? No box plot here because we hit the magic number of 30. First thing I'll get in my do step is my test statistic. Just notice here it's labeled as a T because this is using a T procedure. Oops. That square root should just be on the bottom. Negative 0.97. Need to specify here that this whole T procedure was done with 49 degrees of freedom. P-value is 0.33, which is greater than 0.05. We're going to fail to reject HO. There is not convincing evidence the true mean width of the plastic cubes produced is different than 25.9 millimeters. Okay. Technically, so you can see down here in the conclusion, technically it's produced this hour, right? If they took the sample that hour, it really just applies to, you know. So I could adjust it up here and just say the true mean width of the plastic cubes produced this hour. Okay. Just a two-sided, not a whole lot more going on there. We've seen this before with proportions. Okay, got a 95% confidence interval. This is just some more fathom output. Sample size, sample mean, right? We saw all these numbers. This is what we call n. That's x bar. Standard deviation of the sample, we call that s. That number we call standard error. We talked about those. Working at 95% confidence. And here's our interval, right? And the biggest thing we look for. And we knew it was going to happen, right, when we think about the result, that 29.5 is in the interval, okay? Since it's in there, we don't have convincing evidence that the true mean is not 29.5, right? That interval gives us all the possibilities, right? We're 95% confident that that it captures the true mean, and 29.5 is a possibility.